All right, we left off on number 13 here. I'm just using a new paper. What you have to really watch out for when you factor is this list. Don't just start factoring without checking. You have to go step by step through this list for every problem. Step 1 says factor out the GCF. Now that's assuming there is a GCF. So you have to look at each problem and look for a number factor or a variable that all three terms have in common. Looking at these three numbers, I can divide these first two by 2, but 81 isn't divisible by 2 because it's an odd number. So there's no number that's in all three of these, and there's no letter in common with all three. So I'm going to step 2, look for a special pattern. Well, the difference of 2 squares has 2 terms. This has 3, so maybe it's a perfect square. Grouping, remember, has 4 terms, so perfect squares have 3, difference of 2 squares have 2, grouping has 4. That's how you can recognize them. All right, so now let's check for perfect square. The ends are squares. That's a square. 8 times 8 is 64. 8q is the square root of 64q squared. Because 8 is the square root of 64, q is the square root of q squared. Put it inside a parenthesis with the square. So the ends check out. The middle term has to be 9w times 8q, which is 72qw, times 2, doubled. And 72 times 2 is 144. So the middle term checks out. Then you put 8q, the first sign, the 9w, 1 parenthesis squared. That's the answer. Okay, second one, looking for a GCF. See, I'm back to step 1. Yes, I can divide both of these by 2. There is a 2 in both these terms. First you got to do is pull it out. 2 times p squared gives me 2p squared. Minus 2 times 25 makes 50. Now I'm done with step 1. Step 2 says look for a special pattern. Well, that's just a 2. Here I've got 2 terms, so I would consider the difference of 2 squares. Well, that has a square root, that has a square root. Difference means subtraction. So yes, this is the difference of 2 squares. So you're going to keep the 2. Difference of 2 squares factors into 2 parentheses, one with a plus, one with a minus. P plus 5, P minus 5. So you should have 3 factors in this answer. Okay, I'll start moving a little faster in a minute here. Okay, 27. Oops, where's my checklist? Here's my checklist again. Right, step 1, look for a GCF. There is a 2 in both these numbers. That's it. There's no letter in both parts. So pulling out a 2, x squared minus 16. Step 2, look for a special pattern. This is the difference of 2 squares again. He has a square root, he has a square root. There's a minus between them. So 2 parentheses, one's a plus, one's a minus. X plus 4, x minus 4. So that's very similar to the last one. All right, wait, I skipped a page, didn't I? Oops, 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 oops. I jumped ahead. Sorry, I'm on 15 actually. No wonder that was confusing. Anyway, here I can pull out a 5. And I get x squared minus 9, right? That's a GCF step. Step 2, this is the difference of 2 squares. So it's just like the last one we did. Because this has a square root of x, this has a square root of 3, there's a minus between them. X plus 3, x minus 3. Number 16 has, first of all, it has 4 terms, there's no GCF. It's going to be a grouping problem because grouping is the only one with 4 terms. So I'm not going to give you a GCF with the grouping. Now, you group the first 2, you group the second 2. However, it's minus in the middle. If it's minus in the middle, you got to change the last term. I mean this last sign. Then you pull out the greatest common factor in each group. I'll pull out a 3 in common with the first two. Keep the minus sign. Now there's an m in common in the second two. I'll pull it out. What's left? N times h gives me mh. Minus because it's minus. M times what gives me mk? K. Check your parentheses. They have to match each other. Okay, they do. So now write one of the parentheses. And then the outside stuff goes in the other one. Those are the factors. Number 17, no GCF. This is the difference of two squares. So it's going to have two parentheses. Now the square root is 4y squared, right? You take half of the exponent, 9y squared. One's plus, one's minus. 4y squared plus 9y squared, 4y squared minus 9y squared. Okay, so now we've done step 2. Step 3 says completely factored. That means you got to check to make sure you can't do anything else. This is the sum of two squares because of plus. That's not a pattern, so that's done. These still have square roots, and that's still a minus sign. This one breaks again because the square root of the first piece is 2y, and the second one is 3y. So rewrite the plus piece, 9y squared. The second parenthesis breaks again into two pieces, one plus, one minus. Why do I keep writing 3? 2y plus 3y, 2y minus 3y. 3 factors. Okay, number 18, there's no GCF. Step 2, look for a special pattern. Well, it has 3 terms, so it must be, well, the only choice would be a perfect square. So I'm going to test it. That doesn't mean it is for sure a perfect square, but you got to check it. 100 is a square. M squared is a square. 10m doubled is 20m. The middle term checks. Yes, it's a perfect square. Write the m, write the first sign, write the 10, 1 parenthesis squared. See, it's not 2 parentheses with a plus minus, it's 1 parenthesis with the squared. That is a perfect square. Number 19, step 1, GCF. There is definitely a GCF. 3 is the greatest factor in 6 and 27. Now I'm looking at the letters. X squared, x to the 5th. Well, there's an x squared in both of those because there's an x squared in the x to the 5th. Y to the 4th, y to the 3rd. Well, each has a y to the 3rd in them. This one just has one extra y. That is the greatest common factor. Now, that times what gives me the first term? 2, 3 times 2 makes 6. I already have an x squared. I have y to the 3rd, I need y to the 4th, so I need one more y, minus. 3 times 9 makes the 27. I need x to the 5th, I only have x squared. So I need 3 more y's, and I already have y to the 3rd. That's the end. That's not a pattern. You can't break this down. 2 has no square root. Y has no square root. X to the 3rd has no square root. That's the end of the road. Okay, number 20, no GCF. Let's test for perfect square. 7 squared, m squared, 7m doubled is 14m, checks out. M, first sign, 7 squared. Okay, number 21, 4 terms. This is grouping. Group, group. Minus in the middle means you got to change the last sign. Okay, pull out the GCF in the first group. X squared times x minus 3. Minus. Now, what can I pull out of this one? Really nothing but a 1. So x minus 3. Okay. The parentheses match, so write one parenthesis, x minus 3 times x squared minus 1. Now, this one can break into 2 again. So x minus 3, x plus 1, x minus 1. This 1 has a square root. This is the difference of 2 squares. All right, number 22. That's grouping again. Parenthesis, parenthesis, pull out an x minus 2, plus, pull out a y, x minus 2, parentheses match. So it's x minus 2 times x plus y. All right, this 23, hold on for just a minute. I will be right back. All right, on 23, I can pull out a u squared. Don't change sign. Plus in the middle is standard grouping. You don't change any signs. U squared, 3u minus 1 plus, now I can pull out a 3. 3u minus 1. You're not finished. Write one of these parentheses, 3u minus 1, the outside stuff, u squared plus 3. All right, I think I can, let me finish this page at least. Okay, number 24, no GCF. This could be a perfect square. So square root 12, square root x. 12x doubled should be 24x, but it's not. It doesn't check. Prime. Okay, 25, no GCF. It could be a perfect square. The square root of 1 is 1. The square root of 4m squared is 2m. Square. 2m times 1 is 2m, doubled is 4m. Middle term checks. 2m plus 1 squared. Okay, and number 26 could be a perfect square. There's no GCF. I am checking every time. You're going to have to check much more carefully. Pulling out a 3 is the square root. A is the square root. 3a doubled is 6a. So you get a plus 3 squared. All right,